Hey everybody, so today what we started off with in class here, if you go to my plan book page or even on Teams, I uploaded, it's a slightly different version on Teams. I like this version right here for my Quizlet review game. Anyways, I promise I will make this video shorter together. It will not be 45 minutes long today. But anyways, if you want to go to this Quizlet review game, we played some Quizlet live in class. You guys won't be able to play that game because you need teams and multiple people. But anyways, this is a really cool resource that I got here. So this one, it's called flashcards right here. Just plain and simple flashcards group, group 2 or alkaline earth metals. So groups 3 through 12, that's just talking about the transition metals. Metalloids, who are they? The found along the staircase. Okay, stuff like that. You can go to these other guys on the left side here. Hard, gray, white, good conductors of electricity. Calcium and magnesium are examples of, let's see, calcium, magnesium. Oh, that'd be group 2 guys. So these are the alkaline earth metals. Okay. When a nonmetal bonds with a metal, nonmetal and metal, we call that an ionic bond. Okay, so stuff like that. You can take a test, you can do spelling, you can do writing, you can do math, you can do gravity and stuff like that. But you can do any of these games, and there's just so there's 40 total questions, and they mix and match them in order for you to be able to just answer them in different ways. So that just makes studying a little better. So there's that. Anyways, so today, I think we definitely did hydrogen. Believe we did water. If we didn't, we'll just talk about it real fast. So we know that over here. So these two guys, these are representing our energy level models, right? This is just displaying the hydrogen, the oxygen, this other hydrogen with the full energy levels and the total number of electrons. We're over here as what we're really looking at right now is what we've been moving to is the Lewis dot structure. In our Lewis dot structure, the big difference of our Lewis dot structure here is that these guys, the Lewis dot structures, they show our valence electrons. Wow, and this is not helping me one bit. But anyways, our Lewis dot structure, it shows only the valence electrons. So if we see here oxygen and oxygen here for our Lewis dot structure, we have 8 total electrons here that this energy level diagram is showing. But on our Lewis dot structure, we're only seeing these 6 electrons. We're only seeing 6, remember, because our valence electrons are only shown here. And so if we see here in this valence shell 1, 2, 3, 4, 5, 6 electrons, and that's what we see over here. And how does this oxygen look like this with these electrons? Well, remember, when we do oxygen or we do any element, we fill in these guys one at a time. Make this a little bigger. Here we go. 1, 2, 3, 4, and then we start pairing them up. 5, 6, and that's why these 2 electrons right here are alone, because that's how we fill them out. The reason why we do that is because we want to see that this is a lone electron. This is a lone electron. It would like to pair with somebody. Okay, and how does it do that? Well, this electron and this electron will end up pairing up, and they'll share, right? This is a covalent bond. Covalent bonds, if you guys remember, and then these 2 electrons will end up pairing with each other. So we'll have a single bond here, and we'll have one single bond here. But anyways, what I was going to say here is covalent bonds. We know this is a covalent bond because electrons are being shared. As well as, let me see here, the bonding is occurring. Yep, you can just put that right there, Corey. Thank you. Yep, that's fine. And then bonding is occurring between nonmetals. Okay, I know this looks super sloppy right now, so we'll condense it to right there. So bonding is occurring between nonmetals. Ionic is electrons are being taken or they're being given, and then the bonding is occurring between metals and nonmetals. So we have that positive negative ion. Okay, so we see right here that these electrons are being shared between the hydrogen and oxygen, and we see that right here how it should look like. And then when we see that 2 electrons are paired between this hydrogen and this oxygen, and these 2 electrons are paired between this hydrogen and this electron, we then put a line here that represents, here's a single bond, right? So this really represents this. Okay, so this is what our final guy is going to look like, is right here. And so it says water has 2 hydrogen atoms covalently bonded to an oxygen atom. Methane has 4 hydrogen atoms covalently bonded to a carbon atom. Draw the Lewis dot structure for CH4 using dots for pairs of electrons. Okay, so if I have 4 hydrogens, right? And then I draw it with 1 valence electron. Okay, let me see if I can. Oh, no, I don't want to do that. I was just wanting to copy this guy, but that's not going to work. So anyways, and then I get a carbon. And carbon has 4 valence electrons, and so remember I put 1 electron on each side first. 1, 2, 3, 4. I'm going to see that I need 4 hydrogens, and so this hydrogen will go here. If I had another hydrogen up here, it'd bond here, it'd bond here, and it'd bond here. And so what that's going to look like is carbon, hydrogen. Try to do this as best as possible. Hydrogen, hydrogen, and hydrogen. Okay, and then I see my lines. Okay, there's a nice chemical bond, and there's another bond. Okay, so we have 4 single bonds. Okay, because this is 1 bond between this hydrogen, this carbon. This is 1 bond between this hydrogen, this carbon, and so on and so forth. So remember, each one of these bonds, this line right here, represents this right here. An electron from hydrogen and an electron from carbon are right here in this bond. So when I count around, remember, carbon wants to have a full valence electron, full valence shell, right? So carbon, we know, can hold up to 8 valence electrons because he has 2 energy levels. Hydrogen only has 1 valence electron, or sorry, 1 energy level, and that energy level can only hold a max of 2 electrons, which he wants, right? So he has 2 valence electrons being shared to him. So these hydrogens are now happy. They can only hold up to 2 electrons, and they have, because they got 1 electron from this carbon, and they already had 1 electron for themselves. Carbon now has grabbed 4 extra electrons, or is now sharing its 4 electrons with 1 electron from these 4 hydrogens. So if I count this line has 2 electrons. So there's 2, 4, 6, 8. Carbon now has 4 valence electrons and is happy. So this is what the final thing would look like for our methane molecule. We come down here. It's very similar. So we have oxygen, and oxygen again. We know that this electron would like to share with this electron. Electrons like to pair up. Right here to right here, these guys like to pair up. Okay, so we see this now. These electrons have come together, and we now represent this right here. And so now this is a little different than what we were seeing over here, right? We see a single bond, 2 electrons being shared between 2 atoms, and that's a single bond. Here we see 4 electrons being shared. So we see these 2 electrons, this is now a double bond. Okay, we see it over here, represented in a little different way. But again, we're sticking with this Lewis dot structure, not this guy. So why are there 4 dots between the 2 oxygen atoms? Well, that's just because there's 2 electrons being shared, or there's 4 electrons. The 4 electrons are being shared between the 2 oxygen atoms. Okay. And then we come down here, we do another covalent bond. Again, we know it's covalent because we know oxygen is a nonmetal, carbon's a nonmetal. So nonmetal bondings, those are covalent. We see this again. We see that 1, 2, 3, 4 unpaired electrons around carbon. We see 2 around him, 2 around this oxygen. So if we go ahead and draw some lines, this electron can pair here, this electron can pair with this electron can pair here, this electron can pair here. Okay, so something that we should go over really fast just to clear up any misconceptions. This electron, and I'm just drawing this just to show, but this electron could share with this electron could share with this electron, okay? You could mix and match them and do them every way, but I just do it this way to show that we're covering all of our lone electrons and make sure that they're pairing up, because now we're forming 2 chemical bonds here, okay? And so, or sorry, 2 double bonds. So here's a double bond. Here's a double bond. And now that's represented right here below, right? So we have 2 electrons, so there's 4 total electrons being shared here. 1, 2, 3, 4 being shared here, and that gives us our 2 double bonds. This is carbon dioxide. This is what we breathe out as a gas, right? So why are there 2 sets of lines between carbon and each oxygen atom? And that, again, it's the same thing that's said right here. There's 4 electrons being shared between these 2 atoms. That's why. All right, let's look at this guy. This guy's slightly different. So we have an ionic bond. An ionic bond, electrons are given or taken away okay, and then this happens between metals and non-metals, and that's because we need the charges, right? If we look at sodium, so sodium's a metal. Let me grab my periodic table real fast. Okay. So if I look at my periodic table, we see that these metals over here, right, these guys will become positive, 1 valence electron. These guys would rather give up their 1 valence electron. 2 valence electrons, these guys would rather give up their 2 valence electrons. And that's the only group of metals we're really working with, other than we did aluminum one time. But that he only has 3 valence electrons, so he'd rather give up 3. These guys over here, they have a full valence shell. Here, they have 7 valence electrons, so they only need to gain 1 more, so they'll become negatively charged. These guys will gain 2 electrons here, so they'll become -2. These guys will gain 3 electrons. 1, 2, 3, and they'll become -3. Okay? And so that's why metals and nonmetals, they do this ionic bonds, because they will give and take each other's electrons, because they're oppositely charged. So this sodium, it's a metal, it gives away its electrons. Chlorine is a nonmetal, it takes electrons. So this sodium will give up its electron to this lone chlorine electron here. Chlorine really wants to get to that noble gas status. So when this happens, sodium becomes a positively charged ion. Get this writing way smaller. Sodium becomes a positively charged ion. Down here, chlorine becomes a negatively charged ion. Okay? And when these guys become oppositely charged, they're oppositely charged right now. These opposite charges now attract and bring them together. And form their chemical bonds. Okay, and so that's what's going on right here. And so look at the difference. This is an ionic bond. So this is how we show our ionic bonds. We draw a bracket around them. So sodium lost its one electron, so now it doesn't have any right here. So that's why it has no electrons. It's positively charged. Chlorine gained one more electron, so now it has 8 electrons around its Lewis dot structure. So we'll draw a bracket and a full 8 valence electrons, and it'll become negatively charged. Okay, and this is our final product, like I said, for sodium chloride. We have drawn it like this when we first started learning it, but this gets a little sticky, especially when kids are drawing 1, 2, 3 energy levels and then have to add 18 electrons. This is just much easier to draw sodium with a bracket and a positive sign because valence electrons, they're the only electrons involved in chemical bonding, right? So these electrons inside here of sodium are not involved with the chemical bonds. These 2 electrons, or even these in the second energy level, are not involved with this chemical bond that's going on right here. So in the second diagram, why are there no electrons surrounding sodium? And we just kind of said that. Sodium gave up its 1 valence electron. In the final dot diagram, sodium chloride, the dots between the sodium and the chlorine are between the atoms. So it's talking about these 2 guys, right? If we go back to here, we see these guys right here, and they're being shared, right? We talked about them being shared. But here, are they being shared? It says, are these atoms being shared? No. No. Those electrons belong to chlorine, right? In ionic bonding, there's a giving and a taking of electrons. There's no sharing, okay? So that's the end of your notes for Lewis dot structures, because now on our study guide, we're going to do all of our stuff with Lewis dot structures that only show our valence electrons, because valence electrons are the only electrons involved in chemical bonds. Okay, now that's not to say I might ask for you to draw a diagram with energy levels and valence total electrons. I may ask you to do that still, but when we're doing chemical bonds, you're only drawing a Lewis dot structure. Okay, all right, so there's those notes. Just coming to an end here quickly. Okay, where's my last one? Okay, so now we're here. I'm going to print this guy real fast to my Smart document. Print. While let's cancel that. We'll just wing it right here. All right, so our rules. Okay, we came up with a few rules along the way. So rule number 1, there can only be a max of 2 electrons on the first energy level. Number 2 has a very similar one. There's a max of 8 electrons on levels 2 through 7. And so you may want to know why there's 7 energy levels. And that's because if we go ahead and look at our periodic table, I have 1, 2, 3, 4, 5, 6, 7 periods, and this has all the elements on this period have 1 energy level, 2 energy levels. All of these guys have 3, 4, 5, and so on and so forth, right? We've talked about this. Number 3, then, right? Everybody, the reason why these guys turn to ions, this is the reason, right? These guys lose 1 because they want to look like a noble gas. These guys gain 1 electron because they want to look like a noble gas. Everyone wants to have a full valence shell, right? Or a noble gas. They want to look like a noble gas, if I can spell it. So the noble gases have that full valence shell. These next 2 we've talked about a little bit. This is where we start talking about the bonding. Electrons like to be in pairs. Okay. Electrons like to be in pairs. And then 5 is very similar. When electrons form pairs with other atoms, this forms a chemical bond. Okay? And so we see that if I come back to here, right, these guys are sharing with each other. This is a chemical bond. These two are shared between each other. This is a chemical bond, right? We see this double bond here. Even if we look at our ionic bonds, this electron is coming over here and is still forming a chemical bond because it's pairing up with this chlorine electron here that's alone. Now, we just show it, we don't show it quite the same way when we do ionic bonds, right? So this is our ionic bonds with a positively charged ion and our negatively charged ion with the brackets. That's ionic. Covalent, remember, we don't have the brackets, we don't have a charge, we just have these electrons that show that they're being shared. Okay, so if you guys split this down the middle on the left side here, okay, I want you guys to just show me how many total electrons in the energy level. So here's energy level 1, here's energy level 2, 3, 4. Lewis dot structures. This is only valence electrons. Okay, so you're only showing me the valence electrons for these two guys. These guys are both non-metals, right? So if they're both non-metals, then they must be covalently bonded. So then you're going to draw me an H2O molecule. You'll probably want to print this out. I'd probably go ahead and print this out if you could. If you can't, then you'll need to write it on the paper, on a loose leaf piece of paper. If you do that, please write this. Okay, therefore this atom must be a chemical bond. Show me that this is H2O since I don't have these numbered. Don't just write these down on a loose leaf piece of paper and then expect me to know exactly what you're talking about, okay? But again, if you really can, if you have to go up to the library or something like that and use the printer, I'd really suggest doing that for this worksheet. So anyways, here's that. This, again, this diagram, it's just a visual, right? If you guys remember doing this methane molecule up here. So if you kind of transferred this image to right here, that carbon would be here, and you can put up to 2 electrons on each side for a Lewis structure. And it just kind of helps you visualize what it's going to look like. So here's that methane molecule. You already have the answers to that. It's on the other sheet. But then this is chlorine gas. So this is just chlorine bonding to another chlorine. Okay, it's not chlorine iodide. This is fluorine gas. And here's our ionic bonds. So remember, these guys are going to show the chemical bonds with the line. These ionic bonds, you're going to have brackets, and you're going to have the positive and negative signs. Okay, and that's it. You guys do have another study guide. It's on like the periodic table, talking about groups, talking about atomic symbols, how to find the number of neutrons, which ones are the alkali metals, and it's on that. And those will be due for Tuesday as well, and that's on Teams. Okay, so hopefully you guys are doing well. If you have any questions, please get a hold of me.